Hello, this presentation is for the Introduction to Programming course, and the topic is how computers generate random numbers. Before discussing the role of computers in generating random numbers, it's important to first understand exactly what random numbers are. Random numbers are a sequence of numbers that cannot be reasonably predicted. Why do we even need random number sequences? Because a wide variety of industries need them for a number of different processes, from generating data encryption keys to simulating and modeling complex phenomena, or selecting random samples from a larger data set. The arts world even uses random numbers to create visual works of art. How do we come up with random numbers? They can be generated by classical methods such as throwing a dice, but computers can generate them much more efficiently and faster. But even a computer has its challenges. You are asking a computer that's entire function is based on following a set of ordered steps to behave unpredictably. How do computers generate random numbers? Well, at the very basic level, the computer is given an input by a user or another source and produces an output in such a complex manner that it is nearly impossible from that output to guess the input. There are two strategies to generate random numbers by computers. Pseudo-random number generators use computational algorithms that produce long sequences of apparently random results, which are in fact determined by a shorter initial seed. True random number generators rely on a physical process which is expected to be random. The pseudo-random number generator begins with a seed. A computational algorithm is applied to that seed number that produces long sequences of apparently random results. However, if the seed is known, the random sequence can be reproduced, and this is where the pseudo part comes in. Applications such as DICE, Random Image Script, or Random Link Generator are run by JavaScript. The math.random function returns a pseudo-random number. The implementation selects the initial seed, which in JavaScript is the time on your computer in milliseconds. The seed number cannot be chosen or reset by the user. The true random number generator extracts its random numbers from physical phenomena and introduces it into the computer. Quantum mechanical physical randomness is used, such as radioactive decay, or from atmospheric noise, like during a thunderstorm. An example of a true random number generator is one that is based on quantum physics. Use of decaying atoms creates the most random possible numbers known to man. As an atom decays, it gives off alpha rays. The random time between those rays creates the number sequence, and that is how the numbers for the Idaho State Lottery are chosen. True random number generation is used in data encryption. To transfer information securely, computers negotiate a key between each other and throw it out after it is used. Even if all the steps are known, the key that is going to be used cannot be predicted. Why even bother with the pseudo-random numbers when the true random number generators give more security and produce genuine random numbers? For things like computer modeling and statistical sampling, pseudo-random number generators are the way to go because they can produce many more numbers in a much shorter period of time. How do we know if random numbers that are generated really are random? Well, the thing about being random is that you cannot tell if the return from a random function is random or not simply by looking at the results. How can we verify that random numbers are random? Statistical tests to detect failure are performed. Many true random number generators fail silently, so statistical tests on their output should be performed continuously. For the pseudo-random number generators, NIST has published documents with recommendations on statistical verification. Computer-generated random numbers are critical in this age of information for research and development, solving complex problems, and most importantly, for creating and maintaining information security. However, my personal favorite output is in generative art.
Created using Powtoon.